Welcome everyone to the first lecture of the Mapping the Past in 2025. After the great success of last year's launch and the enthusiastic feedback we received, we are thrilled to continue the series, exploring the intersection of mapping technologies and archaeology with a special focus on Greece and the Mediterranean. Mapping the Past, exploring the intersection of mapping technologies and archaeology, aims to highlight the transformative role of Geographic Information Systems, GIS, and other digital mapping tools in archaeological research. These technologies have changed radically the way we analyze ancient landscapes, the way we reconstruct past environments, and the way we interpret spatial relationships between sites. So by integrating digital mapping into archaeological practice, we can now uncover new insights, we can visualize complex data, and we can deepen our understanding of the past in ways that were previously unimaginable. So we look forward to another engaging and insightful series, and we invite you to join us as we navigate this evolving role of mapping in archaeology. So for today, it's our great pleasure to introduce Dr. Emery Farinetti, who is Associate Professor in Landscape Archaeology and Methods and Theory in Archaeology at the Department of Humanities, Roma Tre University. She specializes in Mediterranean landscape archaeology and GIS application archaeology, bringing a wealth of expertise in the digital approaches to archaeological research. Professor Farinetti directs the Landscape and Digital Archaeology Lab and leads the Archaeoland Search platform, fostering data integration and sharing in landscape studies. She is also a research associate and assistant to the director for research at the Italian Archaeological School at Athens, and has been chair of the Scientific Association CAA Greece Computer Application for Archaeology for the Greek chapter since 2021. Additionally, she leads the Roma Tre Research Unit for the Horizon-funded Argus project. Her research extends across Greece and Italy, where she directs and coordinates several archaeological landscape projects, including the Western Megaris Archaeological Landscape Project, the Monte Lucretili Archaeological Survey Project, and the Ancient Aliartos House Mapping Project. She also leads studies on paleolandscapes and geomatics for the Thracia Island Research Project. Her expertise in GIS, digital methodologies, and survey archaeology has made significant contribution to Mediterranean archaeology. Today, Professor Farinetti will share insights from her extensive research, offering a deeper understanding of how digital tools and landscape archaeology intersect in reconstructing past environments and human interaction with them. So please join us in welcoming Professor Emery Farinetti. And Emery, thank you very much for accepting our invitation.
Thank you, Vasily. Thank you for this flattering presentation. That's not me. It's just a joke. So I will just share the screen. I hope everything goes right because we didn't try earlier. Hope it's fine. Otherwise, you tell me.
Yeah,
No,
I think
fine. Thank you.
Okay,
I think it's fine. Yeah.
Yeah, thank you. So this talk today will explore the current state of GIS applications in archaeological survey, highlighting their transformative role in refining survey methodologies. Within the broader framework of GIS-based regional landscape modeling, we will examine how these tools can enhance our understanding of past landscapes. Drawing on the experience of the Archaeolandscape team from Roma Tre University, I will also present practical examples from the field. The old question concerning the application of GIS in archaeology was how much do our ideas, approaches, and methods shape the capabilities of digital tools? And to what extent do these tools, in turn, influence our practices, introducing innovative strategies and providing new insights from constructing historical narratives? Is this question still meaningful today after the digital turn has almost completely occurred? Digital applications, as we know, including GIS, have in fact become standard practice in everyday archaeology. However, the full employment of GIS technologies needs reflection. As Apostolos Saris has pointed out recently, the different forms of archaeological GIS still entangle the spatial tools of GIS with theoretical and practical issues in archaeology. We'll try in this talk to discuss on the issue by looking at different topics linked to the use of GIS in archaeological survey, such as landscape modeling, data display, data analysis integrated with environmental data, integration of legacy data, big data and large repositories, as well as data sharing and reuse, and the application of mobile GIS in the field. The practice of archaeological survey in 2025 presents a range of challenges which scholars address in diverse ways, depending on the specific context of their work. While terms such as systematic and intensive are commonly employed to describe surface survey methodologies, their practical application often varies significantly. This diversity in tools and strategies reflects the complexity and multidimensional nature of archaeological contexts, but it also introduces challenges regarding the comparability and replicability of the data produced, as Atima, Binkley, and others pointed out in 2020. In the absence of a clear and systematic definition of operational practices, results may become difficult to interpret or reproduce, ultimately undermining the scientific validity of this kind of archaeological research while adding bias to the resulting data. The rapid evolution of modern technologies has further amplified these discrepancies. Therefore, greater transparency in describing methodologies and procedures is an urgent need. Ensuring that data collection is not only efficient, but also comparable and replicable across different projects is crucial. In this regard, the EAA community for fieldwork documentation, named FIDO, provides general guidelines and encourages researchers to share their own practice. In other words, you do your survey however in a way you want, but you need to tell us how and why you did these choices. While discussion continues about the standards to adopt in archaeological survey practices, one thing is clear: documenting and describing our strategies in a thorough and systematic way is essential. This is becoming even more relevant in alignment with the principle of open science, which emphasizes the importance of making every step of the research process transparent, from the data we collect to the methods we use to analyze it. A key tool in managing archaeological build data is the CDOC-Sierra conceptual reference model, which provides a standardized ontology for structuring complex cultural heritage data. This model helps link diverse and fragmented data sets, making them more interoperable across different platforms and disciplines. Its flexibility allows us to integrate excavation records, large-scale landscape data, and more, ensuring that we can work with datasets spanning multiple sources, time periods, and regions. A survey-based section of the model is being implemented right now, as far as I know. This kind of structured, collaborative approach to data management is essential for building a more holistic and accessible archaeological record, where data can be reused, reinterpreted, and integrated across different projects. Studying landscapes requires a holistic, diachronic, and interdisciplinary perspective. This generates a wide variety of data that is not confined to a single topic or chronological period, leading to diverse interpretations and methodological challenges. Managing such data sets can quickly become overwhelming without a clear organization strategy. In this respect, digitization has certainly transformed archaeological survey practices. However, while databases have proliferated, many of them still function as simple storage repositories rather than platforms designed for meaningful data reuse, not only use. Despite technological advancements, challenges remain, especially in encouraging archaeologists to share data openly. Reflecting on GIS gives us a great opportunity to reflect on how big data has reshaped our field. GIS tools are now indispensable for processing, analyzing, and interpreting archaeological landscapes and fieldwork data. These systems handle vast amounts of spatial data and allow us to model past human activities within their environmental contexts. But the key challenge remains: how do we ensure that the raw data, such as spatial coordinates and field records, remains distinct from the interpretative data archaeologists generate during their analysis? Keeping this separation is critical to prevent bias and maintain the integrity of the original dataset, allowing future researchers to revisit and reinterpret the data from fresh perspectives. Large archaeological database and well-structured metadata enhance different levels of investigations while also providing flexibility and interoperability. One particularly important yet often overlooked aspect of this process is paradata, that can be defined as the information that helps us trace the reasoning behind specific operational decisions. Paradata is essential for mapping the thought processes behind our workflows and ensuring that these workflows remain adaptable to different needs. Similarly, the lack of both metadata and paradata has been noted in GIS-based landscape archaeology, where this is often an over-reliance on existing tools for spatial and especially movement analysis. This raises a crucial question. How do we use spatial analysis not just to visualize data, but to critically approach field observations and test theoretical hypotheses? This issue affects all the preliminary work and analysis of the results of the survey in regional contexts. The integration of topographical data and landscape modeling to reconstruct ancient environments and study settlement patterns is one of these topics. Then it's network analysis, site catchment, cost surface, for instance. Then it's visibility analysis and multi-criteria analysis or predictive analysis preceding archaeological surveys. For instance, we can talk about GIS analysis of movement. They can be used to create an interpretative context within which to better understand the character of the sites detected from a survey. The case of the sanctuary of Marmara shown in the slide in Megaris is significant for the territorial organization of the Western Megaris and its position in relation to the city of Megara and the mobility routes between Megara and Corinth. This issue is interesting, especially in the early history of the two cities, marked by strong conflicts aiming at mutual interdependency. As for another example, regional landscape data can be used as variables. For instance, they can be incorporated into GIS-based multi-criteria analysis to develop predictive models for identifying sample zones and selecting fieldwork areas. In the recent years, the creation of the data itself and its processing have become a new scientific discipline, the one of data science, as highlighted by Apostolo Saris in one of his recent articles. In the realm of archaeological survey, however, interest in how the archaeological record is formed and in its integrity and coherence has been present since early days within the survey studies. I'm referring to the work of Martijn van Leusen in his PhD and in the volume of the Regional Pathways to Complexity project. But I'm referring also to one of the first articles on the use of GIS in archaeological survey back in 1999, written by Gillings and Sbonias within the framework of the Populous project. As an example, the intermediate goal of the ceramic survey is to produce visibility-weighted density maps that provide a comprehensive and diachronic representation of the archaeological continuum in a sub-regional context. In order to produce those maps, data have to be systematically collected and their spatial and quantitative dimensions has to be clearly assessed in order to prevent bias in research mainly. Therefore, after fieldwork, the focus shifts to integrated data management, emphasizing the processing and analysis of survey data and the material record. As said earlier, without a clear explanation of operational practices, the data risk being difficult to compare and understand. Additionally, there is an increasing need to structure the archaeological record in a way that allows interpretations and data aggregations to remain modifiable and updatable. the flexibility of GIS systems plays a crucial role in this, enabling this reconstruction process to be replicated in different ways if needed. Furthermore, in order for the survey to be fully systematic, the study of finds is a crucial step. This data is usually systematically integrated into the GIS through a dedicated database. Key outputs of the lab research, including period and functional maps, as well as find stats and diagrams, play a fundamental role in advancing our understanding of the landscape, in the attempt of detecting even the most elusive archaeological landscapes, the visible landscapes, as we call them. Additional technological content has been recently added to laboratory study in the framework of the survey, often supported by advanced digital tools like laser profilers and high-resolution microscopes or denolite, as well as by digital elaboration of archaeometric analysis. Data integration in survey projects, as well as the fusion of all this information in a GIS. This data integration in wider regional landscape projects has always been a crucial issue. The same is for surface survey. A variety of datasets needs to be analyzed jointly with the ceramic record. We're talking about satellite remote sensing and aerial images, terrestrial and airborne LiDAR scanning, photogrammetry, geophysical protections, topographical and historical maps, GPS, GNSS mapping, sampling and coring data for archaeobotanics, for instance, etc. GIS is still the current flexible environment to be used for data integration as the ideal environment for effective data management. As far as data integration is concerned, once again, accuracy, reliability issues, spatial resolution issues are crucial points and keynotes, as pointed out by the majority of recent literature on the topic. The type of data to be integrated vary accordingly to the type of landscape under investigation. Substantial differences occur between rural and urban landscapes, for instance. For instance, in urban contexts, geophysical survey often accompany the artifact surface survey and the architectural survey. Promising experiments have highlighted the potential of integrating geophysical perspectives into archaeological field surveys. In the slide to the right, the example of Aliertos in Boeotia. However, the high cost of these instruments and their primary effectiveness in ancient urban contexts present significant challenges for rural surveys, where optimal conditions are rarely found in marginal rural or upland landscape we usually investigate. Integration is performed also with geomorphological and environmental analysis of the research areas. This analysis is conducted, whether possible, with the support of a qualified expert, such as a geoarchaeologist or a geomorphologist, either before or during fieldwork. They serve to reconstruct ancient landscape, enhancing the visualization abilities of the GIS systems. More often, in the framework of archaeological survey, paleoenvironmental reconstructions are used to interpret paleolandscapes with the use of the analytical capabilities of GIS. Recently, paleolandscape reconstructions are being performed within virtual environment on the basis of GIS layers collected during survey. The aim of geomorphological investigation is also to monitor soil behavior according to pattern of erosion and sedimentation as post-depositional processes. Geomorphological data can be important for this. Multitemporal modeling of soil loss using historical and current remote sensing data can be used to evaluate post-depositional soil behavior involving movement of surface artifacts. In this slide, an example of Rusle model for this purpose. Visibility and preservation of the material scattered over the surface are strictly related to landscape dynamics, outcome of the interaction between surface morphology, climate, and human intervention and activities. In particular, this is a correlation between erosion and sedimentation phenomena and artifact density recorded during field survey. On one hand, this interaction may introduce biases in the recording and historical interpretation of surface scatters. On the other hand, it might lead to the potential dissolution and degradation of the archaeological record through slope wash and weathering. The increased stress on Mediterranean landscape after the World War II often led and still leads to a human-induced land degradation that might eventually turn into a degradation of the archaeological surface record. GIS helps evaluate the landscape evolution during the last century through a multitemporal model of the erosion index and a multitemporal analysis of air photos and remote sensing data, integrated with historical and current environmental data, as performed by Giordano De Coste, for instance, for his master's thesis in the slide. In addition to flashing correct data in the field, the interpretation of the survey data in order to create biographies of territories and sites includes also the reading of legacy data and the integration into the GIS system of this data. A diachronic landscape research typically begins with the study of legacy data, often for bibliographical references or archival data, diverse and heterogeneous by nature. Recently, major databases of Mediterranean landscapes have become available, such as FASTI Online surveys, which was preceded by GIS, if you remember, a few years ago. In addition to FASTI Online, some other noteworthy examples of large repositories include the Archaeology Data Service, the British project ADS, and the Ariadne Infrastructure, a European initiative launched in 2013 to integrate disparate and diverse archaeological archives, and to overcome the fragmentation of archaeological data across Europe, offering a single virtual infrastructure that adheres to FAIR principle. With us is certainly Despina, which I thank also for inviting me. She is involved in this project. Conversely, there are other online platforms created for specific purposes and regions, which are only relatively open. These are often only partially accessible and contain sporadic and incomplete information. For example, some open data section of archaeological platforms provides numerous layers related to different datasets. However, they lack in metadata and paradata, certainly, this way making the archaeological record incomplete and hardly reusable. This highlights the growing need to preserve legacy data, which are at risk due to improper digital management and limited accessibility. In fact, these open data platforms serve not only as starting points, but increasingly also as endpoints where the data we collect in the field is uploaded to ensure accessibility and usability, increasing the potential for global-scale comparative survey studies. There are successful projects that have been drawn inspiration from the British reference model for archaeological data service mentioned earlier. One notable example is the MAPPA project in Pisa. In line with the open access philosophy, a data sharing platform was launched in 2011 to collect and disseminate information from archaeological investigations in Pisa's urban center. Over the years, this platform has expanded to include data from various contexts across Italy. To complement the sharing of raw data in open format, the project introduced Archaeological Data, a journal dedicated to publishing data papers that describe the datasets uploaded to the platform. The concept of sharing behind this project goes beyond the mere exchange of data to make research publicly accessible. Instead, it emphasizes a form of sharing that acknowledges the potential for data reuse, enabling new interpretations that may emerge from perspectives different from those of the original research. Notably, the project has also provided a platform for disseminating research findings that might otherwise have remained unpublished, including, for instance, simple surface surveys conducted by students as part of their master or PhD thesis. As seen earlier, many archaeologists are still hesitant to openly share their data. According to some scholars, this issue should be addressed since the first training period in archaeology at a bachelor stage. The same goal is also pursued by an ongoing project at Roma Tre University. Currently, through ongoing PhD research, at Roma Tre, we're developing a geodatabase for the shared land platform designed to host the data from landscape archaeology research and explore best practices for sharing and reusing archaeological data, especially within the student community. A key objective is to fully harness the potential of legacy data through rigorous and precise source critique, while integrating it with new data collected in the field through artifact surface survey, by promoting a more effective and inclusive use of data in line with the FAIR principles. The project has been named ShareLand, Shared Archaeological Landscapes, Integrating Landscapes for Digital Data Sharing and Reuse, a shared platform for educational purposes and for reflexive, collaborative archaeology. One of the central goals of the project is the development of a participatory and open geoserver infrastructure within the university, designed to facilitate data sharing and data reuse among archaeology students. In fact, the PhD research of Margherita Bottoni and the platform itself have an educational goal. Students are trained in the use of the infrastructure through targeted tutoring, covering not only the practical use of the system, but also the vocabularies and the ontologies applied in the geodatabase. These entities are partly derived from the National GeoPortal for Archaeology, aligned with the Italian standard of the Central Institute for Catalog and Documentation and Ariadne infrastructure. At the same time, a generation of young archaeologists is trained to be willing to make the products of their work available, such as their final thesis or individual research, and to reuse the contributions of others, an indispensable condition for advancing research nowadays. This approach aims not only to facilitate knowledge sharing among young researchers, but also to ensure that data are structured and interoperable, preparing them for effective reuse by the scientific community and the public in the future. A testing phase of the infrastructure is currently underway in preparation for its future semantic implementation. A user survey is currently being conducted to evaluate the platform within the student community. Within Roma Tre University, and in particular the Archaeolandscape Lab, the repositories of legacy data such as ShareLand, together with the wider platforms online, are strictly connected to the collection of new field survey data through a multimodal and multi-scale documentation and an analytic environment. Our approach to archaeological field survey is a multimodal and multiscalar methodology, which is actually our approach builds on the legacy of the intensive and systematic survey practices established by the Biotia survey project led by John Bintliff, but with we add through the use of GIS a multimodal and multiscalar methodology to the basic one. The pedestrian artifact surface survey, which focuses on the intensive and systematic collection and analysis of ceramic shards scattered on the surface, is strictly bonded to the architectural investigation dedicated to the documentation and study of the architectural structures and features visible on the surface, as well as to the reading of anomalies detected through remote sensing techniques. Traditional on-field activities are effectively enhanced by the incorporation of modern and advanced tools for the development of a smart and flexible on-field digital collection process. The toolkit includes high-precision DGNSS devices, LiDAR sensors, and waves and terrestrial photogrammetry, which together provide high-resolution multidimensional data, further enriching the scope and the scale of archaeological field survey. Central to this digital workflow is the use of GIS, which plays a crucial role in integrating and synthesizing various datasets within a single QGIS project. The choice of QGIS is driven by its FOSS status, free and open source software, making it accessible and cost-effective, particularly for training purposes, and highly efficient for our needs. The mobile GIS application connected to QGIS desktop software enables real-time data integration, visualization, and analysis directly in the field fostering an iterative process of self-assessment and in the field refinement of the strategies employed. The display of legacy data within the GIS mobile app and the interaction with these data sets directly in the field has proved to be very effective. Therefore, QField and its QField Cloud plugins are used to streamline our artifact surface survey digital workflow. Initially adopted as a means of bridging the desktop GIS to the work in the field, thanks especially to the work of the PhD student Matteo Rossi, our team is now using QField to design and adapt the survey directly in the field, enabling real-time adjustments based on field conditions or on challenges of the specific context. For the grid-based sampling strategy, the integration via Bluetooth of a differential GNSS device with QField allows us to draw survey units in the field with subcentimetric precision. Is not always needed, but sometimes, as you see, can be. Using the GNSS antenna as a cursor and tablets as digital papers, we can dynamically adjust the dimensions and proportions of the grids to meet the specific requirements of each context. This flexibility, so that you can be in the field and change straight away your survey grid, this flexibility ensures that the density anomalies identified during the survey are optimally framed, facilitating precise and tailored data collection. For the transect-based sampling strategy, we typically design the transect layout in advance using the desktop QGIS platform and then upload it to the devices on the various operators. So everyone has got his own GIS on his tablet or smartphone. Once in the field, the GNSS antenna combined with QField's editing tools allows us to refine the transit layout in response to obstacles that are not clearly visible in satellite or drone imagery. By obstacle, I mean when you cannot cross an area by field working, so you need to change the path of your transect. This adaptability enhances the accuracy and efficiency of our transect-based surveys, streamlining somehow operations and ensuring more comprehensive coverage, even in challenging terrains. Beyond the planning and drawing of survey units, QField plays a crucial role in the documentation process. The survey layers in the app mirror exactly the entities included in the geodatabase created in the desktop QGIS. Using prefigured widgets, each operator can efficiently annotate key data such as pottery, chef count, visibility score, the name of the operator, the working direction, the weather conditions, or the usual information that we record in a survey. And the operators can directly record it by yourself in the app. In this way, the results of their work are instantly viewable by each participant, enabling them to monitor their progress and the progress of the others in real time and ensure data consistency and completeness during the fieldwork. The QField Cloud plugin was introduced in 2022. This plugin enables seamless real-time data synchronization across different devices, ensuring that survey designs and all collected data are instantly shared. Although its full functionality depends, of course, on an active internet connection, this capability enables real-time monitoring and self-evaluation of each field worker directly in the field, facilitating better decision-making by the team leaders and the directors, and the adjustment of upcoming tasks based on the evolving needs of the field survey. During fieldwork, the laboratory can access field data as well in real time via the mobile GIS application, provided an internet connection is available in the field for uploading. This is crucial to maximize coherence in the management of finds in the fields and in the lab. As Vasilis said before, Archaeolandscape is a research team and digital laboratory established within the Department of Humanities at Roma Tre University. Through the several campaigns of fieldwork, and related research, the team has been reflecting on and also trying to refine best practices for the digital collection of data on archaeological landscapes. Archaeological surveys of archaeopaesaggi, archaeolandscape are carried out as part of international projects in both Italian and Greek contexts, primarily involving Roma Tre University in collaboration with other academic and public institutions and research teams. The two main projects are WIMALP and MOLULAP. The Western Megaris Archaeological Landscape Project is led by Roma Tre University in collaboration with the Foret of Antiquities of West Attica and Italian Archaeological School at Athens. The project started in 2019 and aims to investigate the diachronic relations between the city of Megara and its surroundings, as well as the rural use of the area over time. The Monti Locretili Landscape Project is led by Roma Tre University, and since 2020, this project explores an happening upland landscape northwest of Rome and examines the range of socioeconomic and cultural activities that have shaped the historical rural landscape over the centuries. Because of their natural geomorphological differences, these two contexts enable us to experiment with different solutions that are, just somehow sum up in this slide you saw. This is some ideas of how the landscape of Megaris look like and the activities of our project. And this is our project in the rough upland landscape in Lazio, just above Tivoli, close to Rome. Under specific low visibility conditions, we have also experimented with point sampling strategy, which has improved the representativeness of samples collected from challenging terrains where the visibility is very, very low, such as dense forest undergrowth. The site of Brestisa in Megaris, located on a plateau at approximately 600 meters above sea level and enclosed by a fortified wall, in 2021, a terrible wildfire hit the area, burning a great portion of the pine forest covering the site and unveiling new structures. In 2022, we decided to resurvey the site to compare new data with pre-wildfire data. Mobile GIS connected to the DGNSS antenna was effective in allowing us detecting of the ground exactly the same units and unit corners surveyed 3 years earlier, and has proved to be really useful for site resurveying. Since 2020, the team has used a DJI-inspired 3D drone. This drone helped in performing 3D reconstruction of landscape and cultural heritage features through high-quality photographs and photogrammetry. But in 2024, we acquired the DJI Matrix 350 RTK drone equipped with a LiDAR sensor L2, which is currently being tested in the survey contexts. This instrument opens new perspectives, offering the capability to generate ultra-high resolution digital elevation models and significantly enhancing fieldwork analysis and fieldwork planning. Resulting raster DMs are a crucial data source for the analysis, serving as the input for generating various derived datasets that can be integrated with the others within the GIS. These datasets are suitable for a variety of purposes, such as highlighting geomorphological features or reconstructing plausible road networks. The core of the remote sensing processing workflow is once again the GIS framework of each project, which serves both as the starting point for designing field activities and as the end point for integrating sensor data in the form of processed outputs. Currently, we are using QField GIS Mobile to plan drone surveys directly in the field to account for terrain features and obstacles, once again, not visible on base maps. Last summer, we also collaborated with the the Technical University of Cyprus, and in particular with Argyrogiru and Athos Agapiou, as one of their case studies were to test for the semi-automatic recognition of surface archaeological material using AI application. The data are still in process. Data acquisition is typically carried out also for remote sensing alongside the ceramic and architectural survey campaigns, involving a specialized operator, recently the PhD student Federico Fasson, that made these maps. Last but not least, actions of public archaeology and an active engagement of local stakeholders play a crucial role in our fieldwork process. People from local communities are engaged both as valuable oral sources and as active participants in the field as field workers. Additionally, citizens are involved as real GIS operators through participatory GIS mapping labs. To advance toward comprehensive landscape mapping, efforts are underway to develop a system for integrating citizen-collected data using mobile GIS technologies, enabling them to directly report the presence of anthropic features scattering across the landscape, their landscape, or addressing cultural heritage at risk. In conclusion, the GIS approach to archaeological field surveys can be summarized in 3 key points: preliminary source critique, which we value very much, integrating, analyzing, and comparing legacy data with new datasets allows for a critical re-evaluation of existing and freshly collected information. Digital integration. A digital workflow enables seamless integration of processes, enhancing collaboration and coherence. Real-time procedures using mobile technologies. These facilitate real-time analysis, source critique, when we can interact with the legacy data within the app in our smartphone or tablet, and also self-reflection during field operations. So you notice that we really give a lot of strength and focus and importance to real self-reflection during the actual field work. So self-reflection during field operations, providing instant feedback and improving data quality. The survey work is becoming increasingly homogeneous and replicable, with a focus on discussing the processing at every stage of digital data collection and GIS analysis. And with this, we'll go back to the beginning when we stressed out the importance of preparing the data in a way that it can be reusable. And the only way to do this is to add it to the data, metadata, and paradata, and construct the survey according to the way we did it. So accompany the data coming from the survey and involved in every GIS analysis provide them with the actual way we collected and we processed them. Thank you.
Thank you very much.
Thank you, Emery,
for this instructive and very interesting presentation. I think that we can now proceed to the next stage of the discussion with questions to Professor Farinetti. Honestly, I had quite a few questions at the beginning, but most of them are answered. So I'll try to rephrase some of them in order to proceed. I would like to start with the part of education and training. You mentioned training in GIS, and as far as I understood, you combined training in GIS with field work. However, you teach landscape archaeology, and I would like to ask how much of this GIS and broadly technological education is or should be in the university curricula, and what is the situation in Italy today?
Okay, actually, I recently did a survey on this topic, and what turns out is that usually in Italian universities, we were used to train students as far as digital equipment and GIS is concerned during field work. So only people that were taking part in field work, or we thought ourselves at the very beginning that this was the ideal way. So using and just facing themselves with the actual data and the actual procedures, and then being trained to do GIS in GIS. This was almost impossible at the end, in the sense that they did it. The only thing that they knew was through field work, but we didn't have enough time to take care of them and their training. So, and this was something that in every, I would say, a survey we did with them, if they were happy with the course or with the practical knowledge they got, this was really clear. So the situation in Italy is that we are doing this still, but in many universities now, you have laboratories. So it's not proper course. They get the CTS, I'll say, but they're not proper courses. They're still lab, but they're not in the field. They are usually, I say, twofold. So a part in the lab during the whole year. So they have at least 3, even 6 hours per week on GIS or on digital equipments and their use, and then they go during the course outside Rome, for instance, we go, or in the summer or whatever you do field work during field work. So this is something much more complete, because still we don't have courses on GIS in Italy as courses. So they are mainly lab, but things are moving, and also we do a lot, we go effort in many universities now of Italy, paying attention to this idea of big data and involving them into the co-creation of data. Yes, and Pisa, Roma Tre, La Sapienza, and also other universities are very much involved in this. Yeah, I don't know whether I answered the question.
I'm asking that because nowadays we have software that even people who do not have the ability to, the knowledge to code, they can have their own projects in GIS and discuss archaeological questions without simply using this software, just like Word, for instance, when we want to write, or Excel or things like that.
And I would say that this turn into the methodology of teaching as well is because of this. So because of especially in the Mediterranean countries, the university don't have, a lot of funds in order to buy equipments for the students. But this, like QGIS or even QField and on their smartphones, everybody can have it, and use it.
And this leads me to another question. When you do field work, it is easier to, it's not easier. The purpose is to handle data from the field, but in laboratories, in courses, I think that you can, it's best to deal with bibliography. And classical archaeology is a discipline that goes at least back to late 19th century. So there is a lot of data with spatio-temporal aspects that are they were created, these data sets, through more than 100 years. What do you think that it should happen with all this data, and how can we manage them? Should we do this only when we have field work and try to see the old data as you very instructively showed us, or should we start new projects on simply on
thank you for your question, because my talk today was devoted to survey. So this is why I just mentioned this aspect related especially to what is happening in survey. But of course, the majority of data that are inserted in this ShareLand platform I was talking to you about come from legacy data. So it's mainly bibliographical and related archives. And most of the students in Rome, they ask for a thesis on Rome or Central Italy. So they have a lot of historical cartography, for instance, to deal with, or a multi-temporal analysis of aerial photos. So this is something they deal with, mainly this, I would say. The survey integration and the survey integration in the, say, training of the students is something really, young compared to the other. So we've been dealing many years with this legacy data coming, as I in the form of cartography, of maps, not all of them topographically corrected, of course. So we have the problem in georeferencing, which is one of the first things that students learn, or also legacy data from archive. So students go to the superintendency and the A48 archive, the archaeological service, and they get all this information, which is not really spatially, I would say, built. So they have to work a lot on this data to be able to build a GIS on this. Yeah.
Thank you very much.
Yanni, can I ask a question, because it's a little bit difficult for me because I'm in the airport. Yeah. Okay. So you will see me. Hiya. Hello, Emily. Hiya.
Now I realized because you asked me to change a day. Sorry, but yesterday was my day at the airport.
It doesn't matter. No
Okay.
worries. My question is, I mean, I will start from what you said something at the end about the collaboration we had with Athens. So my question is a little bit more generic. Do you think that this semi-automation will be the future in surveys? Because, I mean, I don't know exactly what Athos is. I mean, I can guess what he's doing, but I have listened recently to Orengo from Barcelona,
Yes.
Hector Orengo, that they actually
It's almost the same procedure, yes. In
Okay.
other,
So-
technical is different somehow, but I'm not the right person to explain this.
Yes. So basically, you think that this will be the future, this semi-automatic automation?
I don't know. I don't want to answer now, but I was very happy when Athos asked me to become one of his case studies, because I really want to. We know this data very well, so we know what's in the surface really very well. For the part we selected for the experiment, let's say, we even mapped shirt by shirt on the surface what is there. So. Because I'm very happy and curious to see what will come out. I don't think it will be, I'll say, something that can substitute something else, but can help. For instance, I believe this. I would like to believe it at least. It may help in, I'll say, detecting the survey area. So you can be trained. The machine will be trained to detect shirts from your project, but the same area. And so then you'll be able to use the product and the AI, resulting AI application to detect other areas to survey.
Yes.
That's what I can say up to.
Yes. I mean, it's obvious now that, I mean, we don't go anymore to individual solutions that I'm dealing with GIS and Athos is dealing with machine learning, or Apostolos is doing this and you doing that. We all go for a more holistic solutions that we have to combine all these things together. And if you allow me before I board, I think, hopefully, I found it very interesting, this thing about the citizens GIS. I lost you a little bit there. Are they actually taking part in the GIS project, or they are just doing the field walking?
No. They do the field walking, but then also they come to collective, J and say very interactive laboratories and participatory laboratories. That's how they are called, or living labs, they say, some of them. And we share data with them, and they share data with us. They come next to us and they put their dots in their map, so in the general map of the project, saying there it's something that I know. There, I don't know, my grandfather used to keep his flocks. There, it's a structure that I want to see you. I want to show you. But actually, this in the past never happened, in the sense that they say, I will take you there, but then we never go. While in that case, they get involved in the process. They take part on the creation of the maps related to their territory, and then through the map, then we'll go back to them, and they will show us where the place is, or they can explain to us what something that for us is a strange thing over the surface, for them it has a meaning. So it is actually, it's quite nice when we do this kind of labs, and we do it almost three times a year, 4 times a year even.
Yeah.
Yeah.
No. I mean, it sounds very interesting, because this way, I mean, all these people can get involved, and they can actually transfer their own memories, and they can actually be active. I lost that part, but it's really interesting, and I wish we could do it here. So, very thank you.
Well,
thank
in
you very
Greece,
much.
and not so easy, because I work mainly in Greece, but this kind of activities, it's not so easy, and the issue is not language. I don't have this issue myself. So I tried with this as well, being a foreigner or being, part of the Greek community, but it doesn't work for many reasons. There are also other stakeholders are not very happy with this.
Well, I know.
Yeah.
Thank you, Emma. Thank you.
Professor Farinetti, thank you very much for the speech. It was very interesting. Vasily kind of stole my question, because that's what I wanted to ask. How did the citizen engagement worked? So you pretty much answered the first part. The second part was there any cases where you didn't really think there was something somewhere, and just the citizen information alone lets you discover something new? Because especially when it comes to the place where we are, Thrace, same as other parts in Greece, but here especially the fieldwork is very minimum. So we know about the places, but we have no idea where they are exactly.
Yeah.
So was there any cases where you
yes,
kind of rediscovered
cases.
some?
Yes, before AI application, they were our, guides through the territory in order to select sample areas for survey.
Mm-hmm.
So even before we engaged them in that way, we started engaging them in that way we were just explaining, we always were with them and work with them a lot. So again, in Greece is a little bit more difficult because of other actors in the play. But in Italy, we use it, I've been working in Italy doing surveys since 30 years, and it's very, we always use this method. And I will say use is not the right word. I mean, they really, especially in the last year, they really, co-creating knowledge with us.
No, it's really important. The community engagement is very important. In
interpreting the meaning of the features, especially the one related to traditional agriculture or agropastoral activities. Or, to say this can't be ancient because its grandfather made it. So this is a very great information when you get it.
Actually, that's and also a very important information, because sometimes we see structures and we're like, maybe it's ancient, we don't know, but then nobody's there to tell us, no, my grandfather made it. So that's actually very important as well.
Yeah.
Do they, as a community, do they understand the importance of preserving this information?
Yes, this is a big issue. Because I said that we are in touch, we're keeping in touch and keep touch we build a relationship with the local people, and we've been doing it for many years. But nowadays we are trying to. This is a way to engage local people with their own cultural heritage and history. So with the Faro Convention and the active engagement of local people with their own cultural heritage, this has become a must, something that we as scientists and archaeologists and people dealing with cultural heritage should do. At the beginning was just a way to know, for us to know better their territory and their space and landscape. But at the end, it's something that we can give to them. So they become really engaged with their cultural heritage and with their protection and in order to take care of the cultural heritage. So at the end, it has a social meaning for the contemporary society.
Yeah, it's
And
actually
also,
very, yeah.
No, it's just that something that we use also for, say, training for the students in order for them to be, an active part in this process, not just people that have studied and can say their stories,
Exactly.
but how to deal with the landscape and with the people that live and use and experience, visit it every day or every year for seasonal visitors or whatever.
Yeah, it helps a lot, and I think it's very helpful for the community to get a positive view of the archaeological studies, because sometimes when you go somewhere that is not close to the city, perhaps maybe the people that live there, they don't have such a good perspective when somebody comes to say, I'm going to dig in your, I'm saying it very roughly, but I'm going to dig in your field. But
it is true. But now I can say that it's changing a lot. This,
yes,
so
that's
this is
great.
Not, this
that's
was
great.
the past. It's not. The present is different. The present is an interface. Is the situation, changing situation. But we're going in the right direction, I think, because we see that they get really involved.
That's great, actually. Just to remind everyone who's listening, you can, your microphones are disengaged, but you can post your questions in the chat or in the Q&A chat. We welcome all questions. So everything you want to say, you can ask. So again, thank you, Professor.
No, thank you for inviting me. Yes.
Just to
ευχαριστούμε
mention
πολύ.
that,
Όχι, απλώς να πω ευχαριστούμε πολύ, Έμερη. Νομίζω ότι ήταν... I'm sorry about my Greek. I apologize for that.
Just when she sees Emery, she starts speaking Greek.
Exactly. For some reason, I don't know why. But thank you so much. I think it was a wonderful lecture and very informative. We all learned a lot. And actually, a couple of things I had in my mind before the lecture, you talked about them during your lecture. Okay. So I think it was really great. Yes. Thank you a lot.
I'm happy about it. Thank you. Yes. It was nice being with you. And thank you, everyone.
Just to mention that the whole lecture will be uploaded at our website, and as well there's going to be an announcement in our Facebook as well. I have sent you via the chat the link. Thank you very much.
Thank you.
I think we can say goodbye and see you again, hopefully.
Thank you once again. Bye-bye.
Bye.
Καλό βράδυ.
Καλό βράδυ.
Γεια.